At the individual facility level, impacts of emissions can be estimated through qualitative or quantitative assessments by the use of baseline air quality assessments and atmospheric dispersion models. These methods assess potential ground level concentrations. Local atmospheric and air quality data should be applied when modeling dispersion, protection against atmospheric downwash, or eddy effects of the source, nearby structures, and features of the surrounding terrain. Model selection is dependent on the complexity and geography of the site, for example, mountainous terrain, urban or rural areas. Point sources are discrete, stationary, and identifiable sources of emissions that release pollutants to the atmosphere. They are typically located in manufacturing or production plants. Point sources are characterized by the release of air pollutants typically associated with the combustion of fossil fuels, such as nitrogen oxides, NOx, sulfur dioxide, SO2, carbon monoxide, CO, and particulate matter, PM, as well as other air pollutants involving certain volatile organic compounds, VOCs, and metals that may also be associated with a wide range of industrial activities. Emissions from point sources should be avoided and controlled according to good industry practice based on the specific industry sector. The stack height, for example, for all point sources of emissions, whether significant or not, should be designed to avoid excessive ground level concentrations due to downwash or eddy effects, and to ensure reasonable diffusion to minimize impacts. For facilities where there are multiple sources of emissions, stack heights should be established, taking into consideration emissions from all other sources, both point and fugitive. Fugitive source air emissions refer to emissions that are distributed over a wide area and not confined to a specific discharge point. So they originate in operations where exhausts are not captured and pass through a stack. Fugitive emissions have the potential for much greater ground level impacts than stationary source emissions, since they're discharged and dispersed close to the ground. The two main types of fugitive emissions are volatile organic compounds, VOCs, and particulate matter, PM. Other contaminants like nitrogen oxide, sulfur dioxide, and carbon monoxide are mainly associated with combustion processes. Facilities with potentially significant fugitive sources of emissions should establish the need for ambient quality assessment and monitoring practices. Open burning of solid wastes, whether hazardous or non-hazardous, is not considered a good practice and should be avoided. The generation of polluting emissions from this type of source cannot be controlled effectively.